Sig figs help communicate the quality of measurements and therefore the quality of the result of a calculation from a series of measured numbers. In some instances, we need to count the number of sig figs in a measured number, and these rules help us to do that. First off, any digits that is not 0 is significant. So anytime you see a digit other than 0, you know that it counts as significant. So the only question comes in, what about these zeros? And you'll see that there are different types of zeros. A captive zero is a zero in the middle of a number. It's bounded on either side by significant figures. So captive zeros are significant figures. They do count as significant. Leading zeros, such as these, do not count as significant. Trailing zeros are problematic. This is the way I treat trailing zeros. If they are in a number with a decimal point, they are significant. For example, down here, these are trailing zeros in a number with a decimal point. They're going to count as significant. Zeros at the end of a number without a decimal point are ambiguous. We don't know if they are significant or not. And in this class, we're going to practice using scientific notation so we can unambiguously indicate whether or not they are significant. So we'll just practice quickly determining the number of sig figs in a measured number. And we see here, these are leading zeros. They do not count as significant. And we have the numbers 3, 5, 7. They're all non-zero, so they count as significant. In this case, we have 3 sig figs in that measured number. 409 has a captive zero. That captive zero is going to count as significant. And of course, the 4 and the 9 count as significant. So that number has 3 significant figures. This is Avogadro's number. You'll see it also has a captive zero. That captive zero counts as significant. So this number has 4 significant figures. Here we have the number 508.0. We have 2 different types of zeros here. We have a trailing zero and a number with a decimal point, so that counts as significant. And our captive zero, as usual, is significant. So there's 4 sig figs in this number. Here we have 2 types of zeros. Leading zeros do not count as significant. These trailing zeros and a number with a decimal point do count. So we have 1, 2, 3 significant figures in that measurement. This measurement has 3 sig figs. They're all non-zero numbers in that coefficient. But also we know that any number in the coefficient of a number written in scientific notation are significant. That's how we use scientific notation to unambiguously indicate the number of sig figs in a number. Let's see how that works. Okay, so we see the number 3,000 grams. These are trailing zeros in a number without a decimal point. They're ambiguous. If you answer on an exam with ambiguous zeros, I'm going to write ambiguous on your quiz, and it's going to be marked as incorrect. So if you see trailing zeros with no decimal point, you need to know that you need to use scientific notation to remove any doubt as to the number of significant figures. For example, these numbers here are all equivalent to 3,000 grams, only expressed with different numbers of significant figures. Here we have 3.0 times 10 to the third. There are 2 digits in that coefficient. Therefore, there are 2 significant figures in this answer. 3.00 has 3 sig figs. 3.00 has 4 sig figs. Now on quizzes, what's going to be more common is that you get an answer of 3,000 on your calculator, for example. 3,000 in your calculator. If you know that you need to express that answer in 2 sig figs, you express it this way. 3 sig figs here, 4 sig figs. You use 4 digits in your coefficient.